angle between two vectors. Angle between two vectors. Now, how do we go about this? Now, recall that in our dot product in our last video, that A dot B is equals to A1 B1 plus A2 B2 plus A3 B3, and our cross product will be equal to the vector product will be equals to the determinant, where the first row of is the vectors ijk, the second row are the components of A, and the third row are the components of B. Now, to evaluate the angle between two vectors, we can choose to use the dot product formula and then the cross product formula. Now, the dot product formula says that A dot B is equal to the modulus of A, modulus of B, okay, multiplied by cos theta. And this cross product formula says that the modulus of A cross B is equal to the modulus of A multiplied by the modulus of B times sine theta. So in short, I can say that my cos theta is, if I divide both sides by modulus of A modulus of B, give me A dot B divided by modulus of A divided by modulus of B, and my sine theta will be equal to the modulus of A divided by modulus of B and modulus of A. Now, with respect to that, let's go back to our two examples that we did earlier. So we will evaluate the first vector. Let's say question 1. The first example says that we are given these two vectors. Okay, we are given these two vectors, and we should evaluate the dot product and cross product of each. So once we do that, we'll be able to calculate the angle between them, whether we use dot product or we use cross product. So let's rewrite those questions, where we have vector A is equals to 2i plus 4j plus 3k, and B is equals to I plus 5j minus 2k. And we have for 2, we did P is equals to 3, P is equals to 3i minus 4j plus 2k, and Q is equal to 2i plus 5j minus k. Okay, yes. Now we evaluated the dot product, okay, in the previous video, and we also evaluated the cross product. So let's write out the solutions. Okay, now the dot product in the first case, that is in A dot B, we have 16, and our cross product is minus 23i plus 7j plus 7k plus 6k. So let's write that. We have this to be 16, and we'll have minus 23i plus 7j plus 6k. Now in this example, we have p dot q and also p cross q. So our dot product is minus 16, and our dot product, cross product, is minus 6i plus 7k plus 7j, okay, minus 23k plus 23k. Okay, so we have this one to be minus 16, and we have this to be 6i minus 6i plus 7j plus 23k. Now we will solve this. We will solve the first one using the formula of dot product, that says a dot b is equals to the modulus of a modulus of b cos theta, and we will solve for the angle here also using the formula of the cross product. It says p dot q, let's write in terms of what we know before. The modulus of this is equals to the modulus of a, okay, like we have here and here. Modulus of a multiplied by modulus of b sine theta. Okay, now that we are not using a and b, we are using p and q. So this is p, this is q, will be p, and this will be q. Right. So let's solve question 1 first. So we'll focus on question 1 and we'll solve using this. So from question 1, we'll realize that we have, let's write down the formula. We realize that we have a dot b, as we calculated in our last video, to be equals to 16. Okay, and we have to evaluate our modulus of a, and also we have to evaluate our modulus of b. Okay, so let's write out the question out here again so that we can easily evaluate the modulus. We have that a in our question, a is equals to 2i plus 4j plus 3k, and b is equals to I plus 5j minus 2k. Now, as we recall in our first video of the vectors, we know that our modulus of a will be the square root of the squares, sum of the individual squares. That's 2 squared plus 4 squared plus 3 squared. Our modulus of b will be 1 squared plus 5 squared plus minus 2 squared. Okay, and with respect to this, we'll have that this will give us the square root of 4 plus 16 plus 9, and that will be 29. That'll give us 29, and this will be 1 plus 25 plus 4, and that will give us root 30. Okay, now if we substitute this and this back into our formula, we know that our A dot B was 16. Our modulus of A is root 29. Our modulus of B is root 30. And we have cos theta. Now remember, this will take us back to sort. Okay, and if we don't want to go through sort process, then we can just find the square root of 29, find the square root of 30 using a calculator, and we calculate out. So let's go through the sort process. Okay, we call in our rule of sort, that's the root A multiplied by root B equals to root AB, and root A divided by root B equals to root A by root B. Okay, so that will give us root 29 multiplied by 30, everything multiplied by cos theta. So 29 multiplied by 30 is 870. So 16 is equals to root 870 cos theta. Now with respect to that, we can now divide both sides by root 870. So 16 divided by root 870 is equal to cos theta. Now we use our calculator to evaluate 16. Also first evaluate root 870. We'll have it to be 29.495, and 16 divided by what we have is 0.54245. Now to evaluate our cos, the cos will be the inverse cosine or the arc cosine. That's 0.54245, and to do that, our answer in degrees we will be 57.15 degrees. Now we have solved for the angle between the two vectors. This is to say that the angle between the vectors A and B, okay, is 57.15 degrees. Okay, we solved using the dot product method. Now let us solve the next one using the cross product method. Okay, now let's write down our questions again and our answers. We have that P is equals to 3I minus 4J plus 2K, and Q will be equals to 2I plus 5J minus K. And we evaluated that P dot Q is equals to 16, and P plus P dot Q plus Q is equal to minus 6I plus 7J plus 23K. Now we will recall from our formula that we are using that the modulus of the cross product is equal to the individual modulus multiplied by sine theta. So that will give us modulus P cos Q is equal to the modulus of P modulus of Q and multiplied by sine theta. So we have to evaluate modulus of P cos Q, modulus of P, and also modulus of Q. So let's start with modulus of P cos Q. Since this is our P cos Q, we just have to evaluate the modulus there. And that will give us minus 6 squared plus 7 squared plus 23 squared. And that will give us minus 6 squared is 36, 7 squared is 49, and 23 squared is 529. And to sum it up, we have 36 plus 49 plus 529. We have it to be the square root of 614. Okay, now I want to evaluate the modulus of p. This is our p here. So that will give us the square root of 3 squared plus minus 4 squared plus 2 squared. And that will give me 9 plus 16 plus 4. And that should give me root 29. And q is our q here. And the modulus is square root of 2 squared plus 5 squared plus 1 squared. Alright, that will give us square root of 4, okay, plus 25 plus 1, and that will give us what? Root 30. Now, with respect to this, we can now come here and substitute our values. The modulus of p cos q is root 614. The modulus of p is root 29. The modulus of p is root 30 multiplied by sine theta. Now let's stop here for a minute and look at something very similar. Okay, we can see here that we have quite the same modulus that we had before in the previous videos, in the previous example. Okay, now, and we shouldn't jump to a conclusion that because they have the same modulus, that definitely they should have the same angle, because the modulus, the vector p is 2i minus 4j plus 2k. The vector a is 2i plus 4j plus 3k. Okay, they are two different vectors. Okay, two different vectors and two different questions. So we have this one to be 614, and when we multiply 29 by 30, we have it to be 870 multiplied by sine theta. So our sine theta, that means we are dividing both sides by root 70. Sine theta is equals to root 614 divided by root 870. Now we can apply the principles of sorts. Okay, so we will have this to be 614 divided by 870. So that will give us square root 614 divided by 870. We have the square root of 0.7057. Okay, so our sine theta will be equal to 0.8400. This is 01. So in that case, we can take our inverse sine or arc sine of 0.8401, and theta will be equal to 57.15 degrees. Now we arrived at the same answer of 57.15 degrees, which is similar to what we have here before. So quickly we can pick one final question to evaluate the angle between the two vectors. Okay, now this is question 3. P is equals to 2i plus 3j plus 4k, and also q is equals to 4i minus 3j plus 2k. We can see that which one is faster. We can see that basically the dot product way is faster. Okay, so let's solve using the dot product formula. Okay, now we know that p dot q is equals to modulus of p modulus of q cos theta. Okay, now our P dot Q will be equals to the product of the sum of the product of the individual components. That will be 2 times 4 plus 3 times minus 3 plus 4 times 2. Okay, now this will give us 8 plus minus 9 plus 8. Okay, and this will give us 7. Okay, 7. P dot Q is 7. Now to evaluate our modulus of P, that will give us the square root. Considering this, square root of 2 squared plus 3 squared plus 4 squared, and that will give us square root of 4 plus 9 plus 16, and that will give us root 29. And also if we go around with Q, modulus of Q, that will be square root of 4 squared plus minus 3 squared plus 2 squared, and that will give us square root of 16 plus 9 plus 4, and also that will give us root 29. So let's substitute back into our formula, where we have that P dot Q is 7, and modulus of P is root 29, and modulus of Q, okay, is also root 29, and everything multiplied by cos theta. Okay, so 7. Now this is root 29 multiplied by root 29, that's root 29 squared cos theta. So we can say the square roots can cancel out the square, so we have 7 to be 29 cos theta, or cos theta will be 7 divided by 29. 7 divided by 29 is 0.2414. Now our theta can be a cos of 0.2414, and that will give us, in degrees, we will have 76 divided by 0.03 degrees. Now these are the way to calculate the angles between two vectors. Okay, now it is very essential that to know that the angle, if the vectors are parallel vectors, okay, for parallel vectors, okay, the angle between the two vectors will be 0 degrees, and for perpendicular vectors, the angle between them will be 90 degrees, as the name implies. Parallel vectors 0 degrees, perpendicular vectors 90 degrees. Okay, this is very important. So with this we have been able to know how to evaluate vectors, the algebraic equations between vectors, or operations between vectors, and we can also calculate the modulus of vectors, calculate the dot product and the cross product, and also the angle between the two vectors. And in our last video, we will quickly talk about the scalar, something called the scalar triple product, or the combination of dot product and cross product together. Okay, so